Let us look at 3 maths problems that we can use indices and or logarithms to solve. The first one, we have 2 raised to the power of x is equal to 16. And what we want to do is solve for x. We want to find out what x is equal to. B says 2 to the power of x is equal to 32. C says 2 to the power of x is equal to 25. Alright. Now, what I want you to do is pause the video and solve these. So go ahead and pause. Okay, good. You have paused the video and you solved these problems. Let's look at A. What did you get for A? Let's look at A. You said 2 to the power of x is equal to 16. Now you can say, you can ask yourself the question, what number do I have to raise 2 to get 16? Now, in other words, whatever number this is for x, that's the number of 2's that must multiply to give 16. How many 2's multiply to give 16? If we have 2 2's, well, if you multiply these, they don't give 16. Let's put another 2 and multiply them. These still don't give 16. Let's put another 2. 2 2's 4, 4 2's 8, 8 2's 16. It's 4 2's. So we can say 2 to the 4 is equal to 16. So therefore, x is equal to 2. X must be 2. 4. What am I talking about? 4. X is equal to 4. Alright? Because 2 to the 4 is 16. Another way you can look at it is to say you rewrite 16 as 2 to a power. So both the left and right hand side have the same pattern. So the left says 2 to the x. The right says 2 to the something. 2 to the what gives us 16? It's 2 to the 4. In the powers, they must be the same. So therefore, x is equal to 4. Do you see that? So in both cases, x is 4. So x equals 4 in question A. Now let's see question B. What did you get for question B? Let's work it out. Question B. 2 to the x is equal to 32. You can rewrite the right hand side as 2 to a power. Since you have the left hand side as 2 to a power, you write 2 to a power on the right hand side. The question is, what does 2 raised to give you 32? In other words, if you write down some 2's and they multiply one another, how many of them multiply to give 32? You have 2 2's 4, 4 2's 8, 8 2's 16, 16 2's 32. 2 2's 4, 4 2's 8, 8 2's 16, 16 2's 32. All these 2's multiply. And you have 1, 2, 3, 4, 5 of them. So it's 2 to the 5 that gives you 32. So x is equal to 5. So the answer for part B is x is equal to 5. Good. Alright, let's erase these. Now, question C. You have 2. Question C says 2 to the x is equal to 25. If you raise 2 to the 4, you get 16. If you raise 2 to the 5, you get 25. You don't have a straightforward number that you raise 2 to get 25. But what you can tell is that you are going to have a number between 4 and 5, so it's going to be 4 point something. You might try trial and error and say, alright, suppose you raise 2 to the 4.5, what would you get? 2 raised to the 4.5 equal, it's less than 25. So let's try 2 to the 4.6. 2 raised to the 4.6 equal, you get 24 point something, you're getting close. If you try 4.7, you get 2 to the power of 4.7 equals, well, no, 2 to the power of 4.7 equals, you get 25.99. You have to back down a bit, so it's 2.6 something. Suppose you try 2.65. 2 to the power of 2.65 give you 2 to the power of 4.65, I should say. 4.65 give you, and you get 25.10 something. It's close to 4.65. But then the thing is, I want you to do it very quickly, and it must be accurate to at least 3 decimal places. What are you going to do? You can't do it by trial and error. However, when you look at the laws of logarithms, notice here, you find the log of a number to a power is the same as the number times the log. Look at this. You say log of x to the power of y. If you bring the y in front, this will be equal to y log x with this law. So we're going to look at using that law of logarithms. So what we do here is to log both sides. Let's write down 2 to the x equals 25. Let me put some space between them. I'm going to log both sides. Log of 2 to the x equals log of 25. Okay. Now, if you have log of 2 to the x, this should be the same thing as x times log 2 equals log of 25. Do you see that? Now, let's continue over here. Let's erase what we have here. Now, you want x equal because it's x you want to find. All you need to do is this. If you have x log 2 equals log of 25, what you need to do is divide by log 2. When you divide by log 2 cancels log 2, and all you have left is x equal. But if you divide the left by log 2, you must divide the right by log 2 as well. So you divide the right by log 2. So this will be log 25 over log 2. You see that? There is log 25 over log 2. Now you can use a calculator to find log 25 and log 2. Let's do it this way. Log 25 divided by log 2 equals 4.643855619. Let's put it as 4.643855619. 4.64386. 4.64386. So we have 4.64386 as our answer. Now, let's test it out. What is 2 raised to the power of 4.64386 equal? Very, very close. We rounded off. But you see 25. You see that's 25. So we used this third law of logarithm to solve this problem. Now, here in A, this was a case where you could equate the base of the index. You have 2 to a power equal 2 to a power. You could equate them on both sides. In B, that was the same situation. But in C, you could not do that. So you just have to use logarithms to do it. So here, you have 2 raised to the power of x equals 25. Just log both sides. Log 2 to the x equals log 25. After that, the third law of logarithm says this is x times log 2 equals log 25. And when you divide both sides by log 2 to get x alone, you get x equal log 25 over log 2 and use a calculator to work it out. Now, one more thing. Would it also work with ln? Let's see. What we had here was log log of 25. The common log of 25 over the common log of 2 was 4.6439. Let's try with ln. The natural log. ln 25 divided by ln 2. Now, what's going to happen? Let's go for it. Yes, it worked. 4.6439 exactly. So it doesn't matter if you use common logs or natural log. It will work just the same. So I could have written this by saying ln 2 to the x equal ln 25. Alright? So that could very well have worked. Alright, so we're going to continue looking at indices and logarithms in further videos. So I will see you then.